All right, let's dive in. Today, we're taking a deep look at IonQ, a company that believes it's found nature's own perfect building block for a quantum computer. Now, their whole approach is wildly different from a lot of their competitors, and it just might be the thing that gives them the ultimate edge in this incredibly high-stakes race. So before we can really get what makes IonQ so special, we first have to wrap our heads around the one single massive challenge that every single quantum computing company is trying to solve. Why is building one of these machines just so unbelievably hard? And the answer, really, it all comes down to one word: noise. You see, quantum bits, or qubits, they are just unbelievably delicate. The best way to think of them is like a soap bubble. The slightest little disturbance, a tiny shift in temperature, a stray magnetic field, and pop, that fragile quantum state is gone. The entire calculation is ruined. This constant, relentless battle against a hostile environment, that's the real villain in our story. Okay, so that brings us to our first section. To really appreciate the solution IonQ has come up with, we have to fully understand the problem. This fundamentally unstable, kind of chaotic world that these quantum computers have to live and think in. So here's the crucial point, right? This is not just a numbers game. You can go and build thousands of qubits, but if they're noisy and they're constantly making mistakes, they're completely useless. The real goal, the holy grail, is to build high-quality qubits, ones that are super stable, can talk to each other flawlessly, and most importantly, actually get the right answer. So how in the world does IonQ plan to win this fight against noise? Well, instead of trying to engineer a solution from the ground up, they're actually harnessing something that nature has already perfected. And this brings us to their secret weapon, what they like to call nature's perfect qubit. Now, check this out, because this is a fundamental difference in philosophy. While a lot of their competitors build what you could call synthetic qubits on silicon chips, which can have tiny microscopic manufacturing flaws, IonQ uses individual atoms. Just think about that for a second. Every single atom of, say, ytterbium is a perfect, identical copy of every other one, made by the laws of physics themselves. This natural perfection means way less noise and way fewer errors right from the very start. And this just brilliantly illustrates how it all works. First, they take a laser and zap an atom, turning it into a charged ion. Then, they cool it way, way down and get it ready in its starting zero state. From there, powerful lasers, or more recently, integrated electronics, do all the heavy lifting, performing the calculations by manipulating that ion's quantum state. And for the final step, they just shine another laser on it. If it glows, it's a 1. If it's dark, it's a 0. It's just an incredibly elegant atom-by-atom approach. And this approach gives them two absolute killer advantages. First is what's called all-to-all connectivity. Because the ions are all trapped together in a little chain, any single qubit can interact directly with any other one. It's like having a roundtable discussion where everyone can talk to everyone, instead of playing a game of telephone, which is kind of what happens in a lot of other systems. Second, these atomic qubits can hold their quantum state for seconds. That is an absolute eternity compared to the microseconds of many of their competitors. So, okay, this all sounds fantastic in theory, right? But how does it actually translate into real-world performance? Well, this is where we really start to see IonQ's approach pay off, and they've been making some absolutely incredible progress. To cut through all the hype in the industry, IonQ introduced a really smart new benchmark: algorithmic qubits, or #AQ. The whole idea is simple. Let's stop just counting how many qubits a machine has. Instead, let's measure what actually matters. How large and complex of a useful algorithm can the computer actually run? It's just a much more honest, real-world metric of a machine's true power. And just look at this progression. With every new system, they're not just taking little baby steps. They are making massive leaps in #AQ. They just recently hit an AQ of 64 with their tempo system, which is a huge milestone. And here's the key thing to remember. Every single number you go up in #AQ doubles the computer's useful problem-solving space. This is basically Moore's law on steroids. So what does an #AQ of 64 actually mean? It means the computer can explore a computational space of 2 to the power of 64. We're talking over 18 times quintillion possible states. That is a number so ridiculously vast, it's almost impossible to even comprehend. But remember our villain, noise? Even with this massive computational space, the performance of any quantum algorithm is always limited by errors. Specifically, errors in the 2-bit gates, which are the fundamental building blocks of every single computation. If you get those wrong, the whole calculation just completely falls apart. And this is where the story takes a really dramatic turn. IonQ recently announced they had achieved 99.99% fidelity on their 2-qubit gates. Let me say that again, 99.99%. That means they get it right 9,999 times out of every 10,000, an error rate of just 0.01%. And to be clear, this is not just some small improvement. This is a monumental leap forward for the entire industry. The company called it a watershed moment, and they were not exaggerating. Hitting this level of accuracy is the absolute key to unlocking practical quantum error correction. Think of it like this. If your individual physical qubits are a little shaky and prone to mistakes, you need to bundle a whole bunch of them together just to create one stable, logical qubit that can check its own work. Well, the fewer mistakes your individual qubits make, the fewer you need to bundle together. This breakthrough just dramatically shortens the path to building a truly fault-tolerant quantum computer. All right, so with this core technology now proven to be incredibly accurate, how does IonQ plan to scale up and build truly massive quantum machines? Well, their scaling strategy is just brilliant in its simplicity. Instead of trying to build one single gigantic monolithic chip, they're building smaller, super powerful modules and then networking them together. They're using new chip designs that can pack hundreds of times more qubits into the same space, and they're linking all these modules together using light, essentially creating a networked quantum supercomputer. And this roadmap just shows how incredibly ambitious their plan is. I mean, look at that jump by 2028, around 1,600 powerful, error-corrected logical qubits. Now, why is that number so important? Well, because many experts believe that's the threshold you need to cross to break the kind of encryption that protects almost everything in our digital lives today, from bank accounts to government secrets. So this brings us to the final crucial section, the race for quantum advantage, and where IonQ actually stands right now in this incredibly competitive landscape. And look, the proof is in the performance. In recent head-to-head comparisons against leading competitors, IonQ's machines delivered vastly superior results on algorithms designed to solve real-world problems. We're not talking about a small improvement here. In one case, they found a solution that was 182% better. That is a massive difference. And the market is definitely taking notice. That superior performance is translating directly into dollars, with their revenue just exploding by 222% year over year. This shows that real customers are paying real money right now for access to their machines, and it signals a huge shift from just academic research to actual commercial adoption. And they have the fuel to keep this engine running, and running hot. With approximately $3.5 billion in the bank, they have a massive financial war chest. This lets them focus completely on their ambitious long-term roadmap, investing in all the R&D they need without the short-term pressures that some of their competitors might be facing. And they're already putting this technology to work with major partners. They're tackling drug discovery with AstraZeneca, financial modeling with Goldman Sachs, and manufacturing optimization with Hyundai. This is quantum computing leaving the laboratory and officially entering the real world. So when you put it all together, superior technology, a crystal clear roadmap, IonQ has really positioned itself as a serious leader in this race to build a quantum future. And that leaves us with one crucial, massive question. As they get closer and closer to unlocking the power to solve humanity's hardest problems, and at the same time break the very systems that secure our digital world, are we truly ready for what comes next?